Alright, welcome back to Mr. P-Ups with Calculus. Unit 4, Day 7. We're doing related rates questions, and we're doing them with triangle problems. And you'll see what I mean when I get to them. Quick warm-up here, just once again, what we did on the last video with related rates, which is basically using your implicit differentiation to solve these word problems, where they're going to give you some information, you plug in what you do know, they gave you this information, so you know what DADT is, and then you just solve for there. And you're trying to solve for the radius, trying to find the radius at which this is happening. So they're telling you the area. The area is increasing at a rate of 10 centimeters, so you know what the DADT is. And it's just a matter of solving for radius. All right. Triangle problems. A hot air balloon rising straight up from a level field is tracked by a rangefinder, and from the lift-off point, now we're assuming, a small assumption here, is that the balloon is going straight up. We're assuming that it's a 90-degree angle. At the moment, oh, it does say straight up. Never mind, it's in the question. At the moment, the rangefinder's elevation angle is pi/4, so 45 degrees. The angle is increasing at a rate of 0.14 radians per minute. How fast is the balloon rising at that moment? Okay, well, first thing I did was I made myself a right triangle. I know it's a beautiful hot air balloon picture there. Then I'm going to label as much as I can. It told you that they were 500 feet away from the liftoff, so this is where the person is with the rangefinder. Y is going to represent the height that the balloon is traveling. And we're trying to find how fast is the balloon rising at the moment. So we're trying to find dy dt. All right, so they gave us this as 500. They told us that this angle is pi/4. And we're trying to find how high it is rising. Well, this happens to be the opposite side. This happens to be adjacent side. So the easiest way to do this is use the trig function that uses opposite and adjacent. So that's tangent. Tangent of this angle would be y/500. So that's where this came from. All right, so what I'm going to do here is multiply both sides by 500. What I'm going to do is solve it for y first, so that when I differentiate, I don't really want to do quotient rule over here when I differentiate, so I made it a little bit easier on myself to get dy dt. Remember, that's the whole purpose of this question, is to find dy dt. And when you get y by itself, derivative of y is dy dt. All you have to do is differentiate the rest. 500 times derivative of tangent, you should know by now, is secant squared. So there's your secant squared of theta. Since I know, I'm going to start plugging in the values I know. Once I've differentiated, don't start plugging in until you have differentiated. So now, once I've done that, I'm going to plug in my pi/4 for the angle measure. And it's just a matter of solving the work here. Now, secant, you should know secant is really just your 1 over. It's probably the most efficient way of doing this is remembering that 1 over cosine of x is the same thing as secant. So really, we're just talking about the reciprocal. If cosine of pi/4 is √2/2, then you know you're dealing with 2 over √2. 2 over √2 would just be the reciprocal of. So it's the reciprocal of. So reciprocal of that squared, multiplied by itself, multiplied by 500. Let's see, 2 times itself is 4. 4 over 2 is 2. Oh, really? So it's really just 2. So when you square this, that's pretty easy. 2 times 500 is 1,000. Now, of course, whenever I do these related rates, I do them without the units, and I think about what am I really trying to find and what would be the units of it. How fast is the balloon rising at that moment? We're looking at a rate. How fast? So we know it's going to be a rate at which it happens to be in feet. You don't measure how fast it's rising in feet per minute squared. That wouldn't really make sense. That would not be a rate of a rate. This is just the rate at which it's rising, feet per minute. All right, question number 2. Pretty tricky question because there's one little thing, minor detail in here. I just want to make sure I stress. So if you're looking at through these notes, it says a police cruiser approaching a right-angled intersection from the north is chasing a speeding car that is turning right at a corner and is now moving straight east. So they're at that corner moving straight east. With the cruiser being 0.6 miles north of the intersection, the car being 0.8 miles east of the intersection, the police have determined with radar that the distance between them and the car is increasing at 20 miles per hour. Not quite sure how they got that information, but okay. If the cruiser is moving 60 miles per hour at that instant of the measurement, what is the speed of the car? All right. We got ourselves a right triangle here, so we've got the police car is over here, then the car it's chasing is over here. Remember, this is a squared plus b squared equals c squared. So we got a Pythagorean theorem, related rates question. Now, when you differentiate this, which I'm going to do over here, it looks like, differentiate a squared gives you 2a, this is 2b, this is 2c. To be honest, they're all can be divided by 2. The 2's are really not necessary in this case. Now, the derivative of this, obviously, dA dt, dB dt, and dC dt. The problem you're going to get when you get to here is you don't have all the information. You only have some of the information. What you are missing here, let's see, they gave you A, they gave you B. What they didn't give you is they didn't give you C. So what I did over here was find C using Pythagorean's theorem, which is kind of easy because it's really just a 3, 4, 5 triangle, if we're being honest. So it ended up being 1, which is nice and perfect. So now I know what C is. This was the value that I didn't know that I had to find using Pythagorean's theorem in the red. All right, so now we have this. The only thing that's missing that we can't substitute is dB dt, which happens to be the speed at which the car is driving. And that's really what the question is asking us. So that makes perfect sense. So we plug in all the numbers using substitution, simplify it using our algebra, and we finally get 70 miles per hour. Now, if you mentioned at the beginning of this problem, I said there is a trick here that people will very likely miss and not see. And you'll get an answer of something like -20, which I've done myself, because what you forget to partake here is that this car is traveling south, which means if it's traveling south, and every time we think of up and down, up is a positive velocity, down is a negative velocity. So it's very important that dA dt is -60. And it won't say that in the question because it'll say the cruiser is moving at 60 miles per hour. But since it's moving south, you have to make sure you forget to make it negative. Otherwise, you're going to get a completely wrong answer and it won't make any sense. Now, the car itself is moving east, and east, of course, velocity is always positive. So that's always got to be a positive velocity. And then you end up getting 70 miles. Okay, see, I even put 20 over there. See, I had to check myself. 70 miles per hour must be the speed of the car at that moment of this information. All right, one more question. We have Miss Baxter's father, Mr. Pendleton, was crazy enough to trim the tree with a chainsaw while standing on the ladder. The ladder is 20 feet leaning against a tree. The base of the ladder is pulled away from the wall. Not sure why you would do that, but okay. Don't be pulling ladders away from the tree. At a rate of 4 feet per second, it caused Mr. Pendleton to fall and break his hip. How fast is the ladder sliding down the wall? So we're trying to figure out the speed at which it's... So it looks like we're trying to find dA dt. And once again, like I did on that last question, what I know about this question, without doing any of this work or looking at anything, is that we're trying to find dA dt, and I know that it's sliding down the tree, which tells me that dA dt must be a negative. So if I get anything other than a negative, if I get a positive or 0, I know I did something wrong. All right, so let's get back to the basics. What did they tell us? They told us it's a 20-foot ladder. Now, dC dt is going to be 0 because the ladder's not changing size. It never said anywhere in the question the ladder changed sizes. So as you pull the base of the ladder away, the size of the ladder does not change. So there's no change there. dC dt's got to be 0. dA dt is what we're trying to find. dB dt, they must have given us here in the question. Yes, they did. Now, it does not look like they gave us B. They told us how tall the tree was. They told us how big the ladder was. But before we do anything over here to the right, we have to solve for B. And it looks like it doesn't come out very cleanly as like it did on that last question. Typically, things don't come out very clean. So you use your Pythagorean theorem, we get root 336. Now we found B. So now we do the same steps we did in the last question, and we differentiate a squared plus b squared equals c squared. A very common Pythagorean theorem is used in related rates quite often. You're going to find that. Now, I don't even do the 2's because, to be honest, these 2's right here don't even matter. Everything divided by 2 wipes them out. Plug in everything that we now know. Since we now know, if you get to this point and you have 2 missing things, then you need to go back to the question and relook at it and see what you can figure out. Because there's only ever going to be one thing that you can't figure out and weren't given. And in this case, the thing that we weren't given was dA dt, how fast the ladder's traveling down the tree. So we plug everything else in, we use our algebra skills, and we get this, looks like this irrational answer of -4 times root 336. I'm not going to do anything with that. I'm just going to leave it the way it is. It does seem to make sense to me. I don't know what root 336 is, but it seems like this is, it's falling pretty fast, to be honest. Because that number is going to be, I don't know, about somewhere between 15 and 20 times 4. It's falling at like -60 feet per second. So obviously that's not good. All right, thanks again for watching, and I will see you on the next one. Have a wonderful day.